Okay, young geographers. So yesterday we talked about maps and map projection, simplification, scale, types of map, things like that. And we tried to make our maps, our globes, flat projections on the Earth's surface. Cartography, the science of map making, involves these decisions, and we simulated that yesterday. So today we're going to look at a couple of different types of maps, and we're going to think a bit about spatial thinking and how space is represented on maps, or when we look at any sort of geographic tool, the spatial elements of it we have to consider. So we have a couple of different types of maps. Thematic maps that depict characteristics of places. There are categorical types to show us distinct different kinds. Or there are choropleth that show us different amounts. So you can see the difference there in like desert versus forest versus tundra, or something where we might think about a high value, a medium value, or low value. So to give some examples, categorical map shows the difference between belief systems around the world, and those different colors representing different belief systems, versus a choropleth map that shows us the different regions of the Human Development Index, places with a high level of development versus a place with lower level of development. And then, of course, that should always lead to questions. Why do some places have a high HDI? Why do some have low? Which places are exceptions to expectations? So those are some things that we should always be thinking about when we're looking at maps, asking those particular questions. We could have an isoline map, which is over here, that shows us lines that connect different values. So this would show us like average daily solar radiation. So below this line would be 500 languages, per day, versus 450 out of this line, and so on and so forth. So these lines kind of show us different ranges within a particular area. Dot density does exactly what it explains. It explains the density of some particular feature or phenomena. Each dot represents the frequency of whatever it is that you're mapping. So acreage in potatoes, you could see that there's a density of potato acreage here in these different parts of Wisconsin. We could use proportional symbol maps. These are just simply graduated circles. They show us, again, the frequency of something occurring in a spot. We look at population. The larger the circle, the more the population, and it shows us the location of that. So you can kind of get a visual of places relative to others. You look at Cleveland versus Canton, Ohio. You can see difference in population. And then, of course, there's a symbol map, or sometimes called a flow vector map, where there's typically arrows that are showing the movement of some sort of phenomenon. Typically, we use these types of maps, the vector map, in showing diffusion, how something moved or how something diffused, got from one place to another. We talked about map projections yesterday. So again, the Mercator, the Robinson, and then one that we didn't look at, the Polar, right? But it's always up to the map maker to make those decisions about what's distorted, size, shape, distance, direction, or orientation. Okay. We're moving through some of these things because we already talked about them. We talked about the geographic grid in terms of latitude and longitude. Of course, it leads to the international date line and time zones. And so what I really want to focus then on and now moving forward is thinking about spatial analysis. So when we're looking at some of those maps, whether it be a thematic map, a choropleth map, isoline, whatever it may be, one of the things we have to consider on the map is not only the purpose of it, what it's showing us, but also the scale. And because we're going to use different scales to represent different things. A smaller scale map is going to show us less detail. So we want to use the smaller scale to show more global patterns or national patterns. A larger scale is going to show less land, but in greater detail. So this is what we see in local maps. So as you move through the different scales, you think about like Google Earth, for example, or Google Maps. You zoom out, the scale gets smaller. You zoom in, the scale gets bigger. You see less land area. 1 inch equals 20 miles at the local level versus 1 inch versus 1,250 miles at the world level. So it's kind of like an inverse. Smaller scale, less detail. Larger scale, more detail. So we want to think about scale and analyzing scale. When we think about where things are located and geographically. So let's take the Denver International Airport, for example. It's the only major U.S. airport built since 1980. At the national scale, why did it make sense to build an airport in Denver? At the local scale, why did they build this airport on the outskirts of town in the middle of a field, as you can see down here? Now, to answer those questions, on a national scale, that's where population growth was. People were moving to Denver. This was a major node of power in the Midwest, and it necessitated a new, larger international airport. At the local scale, they built it there because the city was sprawling, and this was where the open space was. So at the time, it was pretty far away from the downtown. The land was cheap. It was out on the edge. So, and it was far away from the mountains, far enough away from the mountains so that weather patterns didn't get in the way. So looking at these types of things, when we look at a map, when we look at phenomena on a map, when we look at any particular place, we need to take into account these questions of spatial perspective and geography. So first of all, when we're looking at something, whatever it is, where is this place, right? Next, we're looking at what is this place? How is this place linked with other places spatially? And that then allows us to get to this level of spatial analysis. What do I see? Where are the edges? Where are the patterns? Where are the correlations? And of course, I have to take into account the scale. And this is all very similar to our 4-level analysis. It's just a way of looking at geography and thinking about what am I looking at and what are the features that I see. So if we take a look at our area, we kind of look at the greater Philadelphia area, we look at this. What am I looking at? Looking at Philadelphia. Where is it located? Well, it's located in between New York and Baltimore or Washington, D.C. I notice patterns. I notice that there are smaller towns around the outskirts of Philadelphia. I notice that there are particular roadways that all travel around Philadelphia. And then we can use that to kind of think about the place and the culture and other patterns that exist there. When we look at maps, we also have to consider pattern analysis. And one of the key concepts in pattern analysis is density versus dispersion. So if you take a look at this, which square mile has a higher density, A or B? Those of you that were thinking B are wrong. Those of you that were thinking A are also wrong. They're the same in this picture. Density simply explains the number of features and the number of phenomenon in a given area, a given space. In this case, 1 square mile. There's the same number of dots in each square. Now, B has a greater concentration of those dots, but the density is still the same. And that's something that we have to think about. This has a greater, these dots are more dispersed, these dots are more concentrated. We think about the concentration or the disbursement or even the density of any kind of phenomenon. We have to think about how the natural environment affects these patterns. So take a moment and think about, perhaps pause the video and think about what phenomena could have caused these different patterns to emerge. So if you were thinking some sort of natural feature like a water border, a mountain range border, some sort of physical natural barrier, you are correct. For this one, we're looking at a node. We're looking at a very powerful, important place. Perhaps it's a city, perhaps it's an Air Force base, whatever it is, and there are things spread around it. In this one, could be a rural settlement. Maybe perhaps it could be a suburban settlement. Or it's very similar to what we look at central place theory later on in urban hierarchy. So these are places that are spread out. Maybe they're connected, maybe they're not, but it's kind of a more spread out dispersion. We're going to do that activity later. So when we look at in the world, thinking about different patterns and how things are connected, what do we know about the world and climate and agriculture? If you take a look at the map and think about where are some places where agriculture is prominent and what kinds of climates exist there. When we take a look at this, climate, agriculture, and industry explain some population density patterns, right? If you look at the patterns here, we notice different concentrations or different population densities around particular areas. These places also have, high levels of industry versus high levels of agriculture. right? Persons per square kilometers, why aren't there any here? Oh, gee, that's a giant desert, right? Oh, take a look here. Wow, one of the most densely populated places in the world. So we kind of think about the connection of these types of things. You have to look at some of the patterns that illustrate the combination between phenomena that we're looking at. And that's a key element of spatial analysis. We took a look at this picture last night, or excuse me, the other day. This is the Earth at night. And again, we talked about it showing a lot of the patterns that we were considering. But it doesn't just show population density, it also shows level of development. Okay. So we're going to spend some time talking about regions at another time. We want to think about different space, and we're going to talk about it in regions, so we will do this activity at another point. The final thing I want to address with maps and analyzing maps for spatial analysis purpose is map aggregation. So how the data is actually presented on the map and how it's kind of divided up. So, this is the percent of 2009 population age 25 plus with a bachelor's degree. The top is the dark green and the bottom is yellow. So we take a look at this nationally. The data is aggregated at a state level. It means we're looking at the state level of a national scale, right? But of course that gives us ranges over here, some percent to another percent. But what happens when we change the scale, right? So the scale can change what we're looking at. So now we look at the Northeast close up. The Northeast looks, a little bit different. When we get close up. And then if we even take it closer in scale, we can see how the data aggregated by county even changes our perspective more. So if you look at, West Virginia, first of all, you look at West Virginia nationally, it's in the bottom layer. It's the brightest yellow on the map. When we zoom in, it's still on the bottom level here in the Northeast. So that might lead us to think like, wow, there are really uneducated people in West Virginia. But when we zoom in, we can see there are some counties here where there are more than 11.5% people with college degrees, and some places where, there's like 8 to 11. So there are areas of West Virginia that do have a portion of the population that's educated. Massachusetts, when you take a look at the same data, Massachusetts up here, looks to be like, wow, 25% of people in Massachusetts have a bachelor's degree. But when you break it down and look at it, there's some areas in Massachusetts that aren't as high as the other ones. Right here, particularly kind of near Boston, you have the area of the really heavy concentration of universities like Harvard and Cambridge and MIT. There's a lot of people with college degrees, but just over a border here, you get into a place where it's less than 11%. A very working class, former industrial area of Massachusetts. And you have some similar borders and places here in Massachusetts. So my point is, when you change the scale, you change your perspective, and that could change the way you look at data. So you have to be careful of that when you're looking at map data. Okay, so taking into account some of these things I talked about in terms of scale, the type of map you're looking at, the purpose of the map, and then how that data is aggregated. Add into that some of those spatial connections and thinking about, what are the connections, what are the patterns that I see in the map, and what does the map tell me? And that can help you both think about some questions and then answer some questions related to, the cultural level and then both the site and situation level of the phenomenon we see. So there is an assignment there dealing with maps. It's titled Totals, where you're going to take a look at a map and you're going to go through a map analysis, thinking about some of the things that I talked about in this short video. If you don't finish it in class, which depending on how fast you work, you may or may not, you do need to finish this for homework so we can talk about it in class the next time we meet. All right, we'll see you then.